Alright, this is chapter 9, lesson 6. This is kind of the practice off page 768. We're talking about permutations, which has kind of a, well, it's an exciting formula because it has the exclamation point in it, which means it stands for factorial, which means that number times every number below itself down to 1. So 7 factorial, for example, would be 7 times 6 times 5 times 4 times 3 times 2 times 1. So this would be read as a permutation of n things taken r at a time. A permutation of n things taken r at a time. So let me just do one here for you. So let's say I had 6 things to choose from and I was going to choose 3 of them. So it would look like this. A permutation of 6 things taken 3 at a time. That would look like 6 factorial. So let me just show you 6 factorial. There's 6 factorial over n minus r. So 6 minus 3 is 3. 3 factorial would look like this. Now what happens is basically the 3 times 2 times 1 knocks out the 3 times 2 times 1 and you end up with 6 times 5 times 4. Now I'm going to teach it a little bit differently because you're taking 3 things. You have 6 to choose from. It means you have 6 choices for the first thing, but after you've chosen one of them, you only have 5 choices left. And then after you've chosen 2 of them, you only have 4 choices left, which leaves us 6 times 5 times 4, which is exactly what we would have got if we would have used our permutation formula. Alright, so let's try that a couple times. Number 1 says I'm selecting the vice president, president, and secretary out of 25 students. Well, that would be I'm choosing 3 things, right, out of 25. Okay? So that would be then a probability of 25 things taken 3 at a time. I would probably teach it like this. I have 25 people that could be the president, which leaves me only 24 choices for the vice president, which leaves me 23 choices for the secretary. So all I need to do is take 25 times 24 times 23, and I get 13,800 possible ways that I could choose that out of a class of 25 students. So once again, this says the probability of 5 things taken 3 at a time. I have 5 choices for the first, 4, then 3, because once I've chosen them, just like in this one, the president can't be also the vice president, so I don't have 25 to choose from the second time. So 5 times 4, of course, 20 times 3 is 60. 4 friends sit in a row randomly. What is the probability Adrienne will sit in the first seat and Julian will sit, and I highlighted the word and there, Julian will sit in the second seat? Well, how many people could sit in the first seat? 4. So there's a 1 out of 4 chance that it's Adrienne, right? How many could sit in the second seat? Well, one of them's already sat in the first seat, so there are only 3 choices. There's a 1 in 3 chance that it's Julianne. So we don't care about the other 2 seats. We're really worried about these 2. And then means that both of these have to happen. It's a compound event. This has to happen and this has to happen, so we would multiply the probability. So there's a 1/4 chance for Adrienne to sit here, and the 1/3 chance to sit here, that Julianne sits here. And so if we multiply those, we have a 1 out of 12 probability. 1 out of the 12 choices are going to be where those 2 are sitting there. Now there are actually more than 12 choices, because remember, there would be 4 people that could sit there, 3, 2, 1. So that would be 24 different ways. There are 2 of those where these 2 people would be sitting in these 2 seats. So 1 out of 12 is your probability.